Hello students. So now classification of Archaebacteria. Okay. So classification of Archaebacteria. Okay. Now again, what is Archaebacteria? Archaebacteria, that means Archaebacteria form a primitive group of bacteria. They are the most ancient bacteria and are believed to have evolved on primitive Earth billions of years ago when conditions on Earth were hostile. Since then, they have survived unchanged and still live in extreme environments like Great Salt, Dead Sea, sulfur springs, and volcanic wells. So, Archaebacteria are known as evolutionary relics or living fossils. Now come to the classification of Archaebacteria. Okay, based on the habitat and metabolic activities, Archaebacteria are divided into three groups: methanogens, haplophiles, and thermoacidophiles. Okay, so based on the habitat, so now based on the habitat and metabolic activities, Archaebacteria are divided into three groups. Okay, those are the methanogens. Okay, methanogens. Next, haplophiles. Halophiles, actually, halophiles. Okay, that is not haplophiles, that is halophiles. And the last one is thermoacidophiles. Okay. Now, first one, now some general features of methanogens. Okay. Methanogens or methanogenic Archaebacteria or methanogenic Archaebacteria. That means methane producers. Methane producers. Okay. Now the features are, they are obligate anaerobic autotrophs. Okay, so they are obligate anaerobic autotrophs. Okay, so they are obligate anaerobic autotrophs. Now next is they produce methane gas from carbon dioxide and acetic acid from sewage in marshy conditions. Okay, so next one is they produce methane gas from carbon dioxide and acetic acid from sewage. In marshy conditions. Okay, that means carbon dioxide plus hydrogen 4H2 that produce CH4 plus 2H2O. Okay, CH3COOH that produce methane and CO2. Okay, so here it is the formula, the production of the methane, formula of production of methane. That means methane is greenhouse gas that leads to global warming. Methane, okay, now methane is greenhouse gas that leads to global warming. Okay, global warming. Okay, so now next feature is they are found in marshes, bogs, swamps, and in the rumen of cattle like cows and buffaloes. Okay, so now they are found in marshes, bogs, swamps, and in the rumen of cattle like cows and buffaloes, like cows and buffaloes. Okay, now next feature is methanogens help in fermentation. Now next feature is methanogens help in fermentation. Of cellulose. Cellulose. Okay. They do not they do not decompose the organic matter but utilize the end products of decomposition. But utilize the end products of decomposition. And products of decomposition. Now next is halophiles or halophilic archaebacteria, that means salt lovers. Okay. Now next is halophiles or halophilic archaebacteria, that means salt lovers. Okay. So now the features of halophiles is they are aerobic or facultative anaerobic heterotrophs. So they are aerobic or facultative anaerobic heterotrophs. Now next, they live in saline environment in salt lakes, marshes, brine, that means salt solution, and salt rich soil, where salt concentration varies from varies from 2.5 m to 5.0 m. Okay. Now next, they have high intracellular salt concentration. Their enzymes are ribozymes. Their enzymes and ribozymes function efficiently only at high salt concentration. Only at high salt concentration. So now next is they have special photoreceptor pigment such as bacteriorhodopsin. Due to the presence of bacteriorhodopsin, halophiles become purple to harness solar energy in strong sunlight. This serves three purposes. So they have special photoreceptor. They have special photoreceptor. Pigment. What is it? Bacteriorhodopsin. Okay, bacteriorhodopsin. Due to the presence of bacteriorhodopsin, halophiles become purple. to harness solar energy in strong sunlight. Okay, these serves three purposes. Number one is protects halophiles from strong solar radiation. And it helps in the synthesis and of ATP, and the last purpose is ATP synthesized during this period is used under conditions of oxygen stress. ATP synthesized during this period is used under conditions of oxygen stress. Okay, now next feature is nutrition is chemoautotrophic. Nutrition is chemoautotrophic. Okay, now come to the some examples. Halococcus. Okay, Halococcus, Halobacterium. Bacterium. So those are the examples of halophiles or halophilic archaebacteria. So now, bye students.